Hello, my name is David Chandler, and I have a company called Math Without Borders. And what I've done is I've recorded the courses from Algebra 1 through Calculus, the whole high school curriculum, primarily aiming at the homeschool families, people that are educating their kids outside the normal institutional schools. I like to focus for this little presentation on some of the things I've done in geometry and some of the techniques I've used, and I don't know if others of you are using these kinds of techniques or not, but maybe you can learn from this. But also, I have some suggestions for the developers of GeoGebra on how to make some of these things work a little more fluently. Okay, in these examples, I'm not really focusing on the mathematics here. And so, for instance, the altitudes for this triangle would be the perpendicular from each vertex to the other side. The medians are from the vertex to the midpoint of the opposite side, and so forth. So each of these are defined in a different way, and then here's a little line connecting three of these in a straight line, it turns out. And the main thing I wanted to focus on here is the use of these checkboxes. The default behavior of these checkboxes is you can just basically select as many of these as you want. Each of them turns out to be a Boolean value. And so either true or false, and based on the value of these boxes, you can display or not display certain constructions. The clear box I made a little different, and so what I did was so that if this one is checked, let's look at this. If I go into the object properties for this and go into scripting, notice that what I'm doing is I'm setting each of these values over here to false. Okay, so I'm turning off all the other boxes. So that's the first example of a little bit different use of these boxes, is rather than just say yes or no to a bunch of different things and turn them on and turn them off, I can let the value of one box determine the values of the other boxes. Okay, here I'm using checkboxes in a little different way. Notice if I check the first box and I check it a second time, it stays on. And if I check the second one, it stays on, but the first one goes off. And this one, if I check it, it goes on. No matter how many times I check it, it stays on, and these others are off. Okay, this is the behavior of something called radio buttons. And normally in programming, you would see this is a circular region rather than a square. And one of these buttons would always be on and the other two would be off. I'm modifying it a little bit from that. Notice that step 3 brings up another pair of options. This is divided into 3 parts, or this is divided into 5 parts. Notice that those are behaving sort of like radio buttons as well. Okay, and then I do have a clear button that does in fact turn everything off. So let's see how these are implemented. Notice if I hover on step 1, it says Boolean value I1. That's this value right here. Step 2 is I2. Step 3 is I3. And if I click step 3, then I can see this is J1 and this is J2. All right. Now, if I go into step 1, go to object properties and scripting, notice that what this step is doing. It sets I1 true. I2 is false, I3 is false, and then J1 and J2 are false. So clicking step 1 is going to turn these off, it's going to turn these others off, and it forces this one to stay true. Notice if I click it again, this one stays true because the logic forced it to be true. So that extra thing wasn't just a redundant step, it was actually what made this forced to be true. All right. The only way to get this off is to hit clear, which clears everything. Okay. By the way, I didn't put that behavior here. I can divide into 3 parts, or I can divide it into 5 parts, and these are exclusive of each other, but I could in fact turn off one of these just by clicking a second time. I didn't put that functionality in it. So I can actually just say, all right, here's a bunch of evenly divided spaces, which, by the way, you can space any way you want, just in terms of the geometry. And notice it doesn't affect where the dividing points are. Sort of an interesting little feature of the geometry itself, but we're not focused on the geometry here. Okay, so down here, if I look at the object properties for J1, notice all it's doing is setting J2 false. Had I wanted these to really be like radio buttons, so one of them is always going to be true, and clicking it a second time doesn't alter it, then I could have put that in there by just saying J1 is false and J2 is true, but I didn't bother to do it that way. So radio buttons are a missing feature in GeoGebra, but you can implement radio buttons and other behaviors of the buttons rather flexibly using the scripting. Okay, I'd like to turn to something else now. Here I have something I want to demonstrate using an animation, and there's going to be several stages, so let me just run through it. And what I'm taking is originally a prism, and I'm splitting it into 3 pyramids, and what I want to show is that these pyramids, even though they're not congruent to each other, do have the same volume. And so then if I compare A and B, I can put these side by side. They have the same base, they have the same altitude, therefore they are the same volume. If I compare B and C, they have equal bases, they have the same altitude, therefore they have the same volume. And A and C, notice these opposite faces are congruent, and then they have the same altitude, and so they have the same volume. So if all of them pairwise have the same volume, then they're all 1/3 of the original. So the original prism has a volume that's the area of the base times the height, and the volume of a pyramid would then be 1/3 the area of the base times the height. So that's the basic math involved here. Let's see how to implement this. Notice I want to do a series of steps. This variable here, the number over here, is indicated by the lowercase letter o. As soon as it's non-zero, this division appears, and as I go from 0 to 1, once it gets to 1, then it starts the second movement, and from 1 to 2, it comes down here. Once it gets out to 2, then I have all these other things appear. Now I have these sliders which do the same kind of a maneuver except on different objects. So compare A and B. Notice that this slides this over there, and going from 0 to 1, see it's 1.16 at this point, and then it stays there until it gets to 4. And when that number gets to 4, it starts going back, and at 5 it returns. So this is one stage of movement, and then from 1 to 4 it's just sitting there, and then from 4 to 5 it's moving back. Okay, and same with these others. And then reset puts everything back where it belongs. Okay, that's a pretty complicated application of this. I'd like to show you another demonstration. So the point is really to illustrate how this multi-step slider thing is implemented. Okay, here's a project problem that was in the book, and it asked the student to prove that if you have a point in the interior of an equilateral triangle, and you sum the 3 distances from that point to the 3 edges of the triangle, that the sum of these 3 distances is equal to the altitude of the triangle. Okay, so you can position this wherever you want, and then this demonstration is going to actually prove that by doing a series of transformations. So let's just run it to see what it looks like. Okay, so what we've done is we've taken those 3 lengths, rotated them around, and lined them up to be equal to the altitude. All right, notice that the value of the slider here is now 6. And so if I go back and realize that it's the slider that I really want to focus on rather than the interesting geometry here, notice that going just anything off of 0, from 0 to 1 actually, it's just simply sitting there with the triangles displayed. So the triangles are the key insight. If I can draw these triangles, then I can do the rest of the problem. Once it gets past 1, it starts rotating this line segment here. And so it's rotating it at the centroid, and There we go. And once it passes 2, it rotates the next one. And once it gets past 3, it starts that slide. Once it goes past 4, it does this. Once it goes past 5, it does this. So what I've done is I have a timer here essentially, and I've broken this down into 6 stages, from 0 to 1 and up to 6 eventually. Okay. By the way, notice that no matter where I move this, even after the fact, the whole construction follows along. It's sort of interesting. Okay. Sort of neat the way GeoGebra works, that all of these things can be linked so easily. Okay, let's see how this is implemented. Over here I have the value of A, which goes from 0 to 6. Then I have these other numbers here, which is A1, A2, A3, A4, A5, and A6. Let's take this back to 0 and watch these numbers right over here. So here A is 0, and here A is approaching 1. And notice that A1 just tracks A exactly. And once I pass 1, A1 just sits at 1. It caps off at 1 and won't go higher. And A2 is now equal to the fractional part of A. So this is A minus 1. And then A3 is now equal to the fractional part of A. It's equal to A minus 2, and so forth. And so each of these, they start off at 0, and once they're active, it changes from 0 up to 1 gradually, and then once it gets to 1, it just stays there and doesn't go beyond that. Let's see how these work. So for A1, if I go to Object Properties, notice A1 is defined so that if A is less than 1, it takes the value of A. Otherwise, it takes the value of 1. Okay, so that's what we're observing. Back here, as long as A is less than 1, this is equal to A. And once it's greater than 1, if I go up here, so now I'm greater than 1, A1 is simply 1, and it stays there. If I go to A2, it's a little more complicated. Here, if A is less than 1, it has the value of 0. Otherwise, if A is less than 2, I subtract 1 from A, and that's its value. And then otherwise, it's going to be 1. So in other words, this is going to only be affecting the value. A will only affect the value of these other numbers when A is between certain integer values. Okay, so it sequentially moves one then the next. Okay, so my comment about this procedure, first of all, is it works, and it's sort of a nice thing you can actually do with GeoGebra as it stands right now. However, the feature as implemented in Geometry Sketchpad allows you to define individual movements, and then you can stack them one on top of the other. So first, one movement would occur. When that finishes, you can specify a time delay, and then the next movement occurs, and then you can have a time delay, and then the next movement occurs, and so forth. So you could actually string together the sequence of movements with a much more natural kind of a programming style. So I would encourage the developers in GeoGebra to implement something like that. In the meantime, this I would consider a workaround, and in fact it does open up quite a bit of flexibility, but it requires quite a bit of low-level programming on the part of the user.